Well, dear friends, in last video I told you what is mutual induction. Now here in this video we will discuss how does the value of M depend on geometrical shape and size. So here are two concentric coils of radius R1 and R2, and here R2 is very much less than R1. Why this taken I will explain. तो टू कॉन्सेंट्रिक सर्कुलर कंडक्टिंग लूप्स के लिए हमें निकालना है M. तो here we can pass current through the inner or outer coil, but it is easier here to calculate M by passing current through outer coil, because at the center मैग्नेटिक फील्ड जो हमारा है फी बी इक्वल टू म्यू 0 I अपॉन 2R. दिस इज द फॉर्मूला फॉर मैग्नेटिक फील्ड एट सेंटर, एंड हियर फील्ड इज इन द होल लूप इनसाइड. नाउ if we pass current here in this coil, then field here in this and here outside, so calculation will become difficult. So let me pass current I1 through outer coil. Let me figure current I1 is passed through outer coil. The magnetic field at center of two coils, because they are concentric, of two coils is given by B1 is equal to mu 0 I1 upon 2 pi R1, 2R1. This formula is meant for the field at center only. But here, since R2 very much less than R1, so magnetic field at every point inside the inner coil is said to be, is supposed to be equal to magnetic field at its center. Magnetic field at its center. So magnetic flux linked with inner coil phi 2 B1 into pi R1 is R2 square. Field due to this coil here supposed to be same everywhere, into this everywhere, and B1 equal to mu 0 I upon 2R1 into pi R2 square, or the mu 0 pi R2 square upon 2R1 square, 2R1 only, into I1 phi 2. Comparing it with NS phi S, is equal to MIP. We get M is equal to mu0 into pi into R2 square upon 2R1. This value of M has been asked many times in CBSE board. So don't go that these are not extra, these are essential to know. These are fundamentals of physics. Please try to understand what is physics. People generally remain behind mathematics of physics. But we should understand what is physics in any phenomena. How the light is emitted by LED. How we are communicating. Try to find out. We are communicating through mobile phone. And when I ask student, they say, sorry sir, we don't know. So that way is not good. Now next here is mutual inductance. Mutual inductance of two long coaxial solenoids. I am telling you almost everything which you need to complete any exam. I keep on telling the numerical also the same way. So please, if you like, you please share and ask your friend to subscribe my video, my channel. They will be benefited without going anywhere. Time is a big factor. Don't waste time. If you are getting it at home, what is the harm? It is the actually biggest hobby. Learning is the biggest hobby. Generally people ask, what are your hobbies? I like to play badminton, I like to play football. Okay, I like, but science students have to work hard. You can play, you can give time to your games, hardly 30 minutes, not more than that. But when you play, you forget time. So what are two coaxial solenoids? Now see, I am drawing here diagram. This is one solenoid. There is another inside. The two have same axis. Let outer coil be 1 and 2. To this area A1, this area A2. Here number of turn N1. N1 turn. Here N2 turn. Both the two coils have same length. In NCERT diagram is drawn other way also. They have made a spiral spring. So let N1 is the number of turn outer coil, N2 here. Area A1, A2. Let current I1 is passed through outer coil. I1 current. I1 current is being passed in the outer solenoid. You can take inner also. No, there is no problem in it. Is the I think diagram clear to all of you. These two coaxial solenoids are there having common axis, area different. They may have nearly same area also. We can wind up the two coil of insulated wire on same core. The solenoid may have many layers on itself. You can wind other, but wire should be insulated so that they should not touch each other. Actually, insulation is on the surface, and the chemical insulation is there in such cases. Now, let I1 current is there to magnetic field at every point near the center. B1 equal to mu 0 N1 I1 upon L. N in number of turns. This is field is near the center, but the variation is small. Assuming the field same everywhere, to magnetic flux linkage with inner solenoid, it will be N2 B1 A2 magnetic flux, but it is N2 phi 2. Phi is this B1 into A2, or N2 into B1 is mu 0 N1 I1 upon L into A2, or you can write here it as N2 phi 2 is equal to mu 0 N1 N2 A2 upon L into I1. So simple. Again comparing it with NS phi S is equal to MIP. Comparing it with NS phi S equal to MIP. Comparing these two, we get M is equal to mu 0 N1 N2 A2 upon L. The same value of M will be obtained when we pass current through inner solenoid. Actually, when we pass current through inner solenoid, magnetic is only here. So when we will be calculating magnetic flux with this, then that will be B2 into A2. Phi Q field outside is 0. This area will not be taken. Only this much area will be taken. So you will get the same value of M. If the two, these are core is filled with magnetic material, then M is equal to mu 0 mu R N1 N2 upon A2 upon L. Now, sometimes people talk in terms of number of turn per length. So if N1 is equal to N1 upon L, or N2 is equal to N2 upon L. Small N1 and N2 are the number of turn per length. Then here N1 is equal to N1 into L, N2 is equal to N2 into L. So M will be there, mu 0 N1 L into N2 L into A2 upon L. This L cancel. So we will get mu 0 N1 N2 A into A2L. This will be the mutual inductance of two solenoids in terms of number of turn per length. I hope this is very important topic, dear student. Generally asked. And I will be telling you a question here. So now I have finished this self-induction, mutual induction, their coefficient. Now there is a question here, because I have got time. Question is there, okay, if L1 and L2 be the self-inductance of two coils, and M be their mutual inductance, let L1 and L2 be the self-inductance of two concentric solenoid of area A1 and A2, and say here कि A1 greater than A2 and MB the mutual inductance then prove that M is less than under root L1 L2. M is less than M1 M2. Two concentric solenoid A1 I have taken greater than यानी कि this L1 outside coil है like this. This is A1 here and other is A2. So we have to prove M less than under root L1 L2. First you write L1 mu 0 N1 square into A1 upon L. L is the same. And L2 mu 0 and 2 square, it is A1, it is A2 upon L. And M is there equal to mu 0 M1 and 2 A2. Inner coil का ले जाएगा area A2 upon L. These three formulae should be known to you very clearly. Please start learning, start keeping the facts in your brain. Actually, if we stress you, I may be criticized that you are making student to cram. Yes, cramming to must have after learning the thing. If I don't remember my name, then how to make my identity clear? So here, what to do? L1 and 2 multiply it. You will get mu 0 square, N1 square and 2 square, A1 A2 upon L square. Then make M square here also. M square equal to mu 0 square, N1 square and 2 square and A2 square upon L square. Divide these two, यानी कि M square upon L1 L2. You will get cancel this N1 square and 2 square cancel. And you will get here only mu 0 square cancel. You will get A2 square upon A1 A2. Or it is equal to A2 upon A1. A2 upon A1. M square upon L1 L2. But A2 less than A1. So M square upon L1 L2 less than 1. Or M square less than L1 L2. Or M less than under root. This question was there in sample paper of board. CBSE issued the sample paper in which this question was there. So please, if you like my video, if you like my teaching, then ask your friend to follow me and ask them to subscribe my channel. That will help you a lot. I don't say that I know everything, but I try my best. Thank you.